we are going to see we are going to see paper 3 chapter 1. This example every year they are asking. They are conducting energy audit on process plant. The plant has a contract demand 5000 kVA. The average maximum demand this plant has 3850 kVA per month. The power factor also have. The maximum how they calculating is a 30-minute cycle. They are averaging the 30-minute cycle. The cardid. The maximum bill is a 600 rupees per kVA per month. The minimum bill level, minimum bill level is 70% of contract demand. This minimum bill 70% of contract demand. Next, incentives. They are giving the 0.5% reduction. Energy charges for increasing 0.01 increase in power factor. They are giving the 0.5% reduction for improve the power factor 0.01, and this is a limit they are giving above the 0.95. The average energy charges is 18 lakhs per month. Then next they planned decided to improve the power factor 0.95 to unity, and we need to calculate it KVA rating, how much capacity we need to add, and that we are going to add this capacity, then maximum demand also reduce, then annual reduction charges, and we have to that component about how much we are going to install installation cost, and then payback period we need to calculate. For capacitor, these are giving the data. This is a rupees 900 rupees per kVR. Then we are going to see that remaining part. They are spending the money. Then what are the cost saving? Then finally they need to calculate how long it will take to recover that investment amount. This is a simple calculation. This calculation I have made one triangle concept. You can easily remember this concept. This is a triangle method. You already have the old input and you have the old output, this old process. Then we need to improve this new input means process different process. We have to improve that our power factor improvement, maximum demand reduce, and KVR we are adding the KVR. Then so you have to calculate this whatever the new input, new calculation, new charges, then old charges and new charges you have to minus, then you get the new feedback, cost saving, what are the improvement system. This is a simple, you can easily remember this triangle. This is same concept they are using all the example. The calculation they have to based on this system. They are giving the already old system, old input, then old process, then you depend on the old output, you have to make the new process and you get the new input, then old input, new input, both you have to what are the changes available from old input to old input and new input, then you get the new feedback, new cost saving system. You have to remember this one. Then our calculation, this is going on. The contract demand, and average maximum demand, power factor already 0.95. The maximum demand is billed. This is a maximum demand 600 rupees per kVA per month. Maximum demand billable, this is 70% of contract demand. This is a minimum billable maximum demand is always 70%. And incentives, they are giving the 0.55 reduction energy charges of electricity bill from every 0.01 increase in power factor. Then 0.5 reduction charges equal to 0.01 increase power factor. The power now the concept is power factor improving 0.95 to unity power factor. This is that some summary. Only you have to with a solution. You have to write first step 1. How much kilowatt round? Already we know maximum demand power factor. You multiply, then you get it kilowatt. This kilowatt you got it. Next step 2. You have to calculate it capacitor, how much capacitor required. Power factor 0.95 to 1. You are going to improve this power factor. So this formula, this is important formula. Kilowatt whole multiplication tan pi 1 minus tan pi 2. This is a pi 1 is old angle. This is a old power factor angle. Pi 2 is a new power factor angle. Then you got it pi 1 value. This is cos inverse of 0.95. Cos pi 2 is cos inverse of 1.0. This value you already know kilowatt 3657.5 whole bracket 0.329 minus 0 whole bracket. Then you got it 1203 kVR. You understood this one? If you not understood, just note it where you got stuck, because we are going to improve the here system going to power factor 0.95 to unity power factor. This is we are going, it is going to here. So you need to calculate this only on KVR, whatever, only the this what are the KVR required, only you have to calculate. This is a formula for this one. Next step 3, cost of capacitor. This already we calculated 1203 kVR into multiplication into already you know 900 rupees, then total 10,82,700 rupees. This is a one-time installment. It's a one-time installation. Next step 4. Next step, already we need to find maximum demand at unity power factor. Here we know 3850 is a old maximum demand. Now our system moved from 0.95 to unity power. So you need to calculate accordingly. Already you have the 3650 by 57.5 kilowatt divided by power factor 1 is a formula. KVA equal to this kilowatt divided by power factor, the cos by. Then you got it KVA 3657.5 kVA. Next step 5. This is a final KVA maximum demand. This is we know they are always charging 75% of contract demand. This is a contract demand 70%. So contract demand is 5000 into 0.75, 3750. Always they are charging for 3750 kVA. Then this is the base value. Then 3850 minus 3750. This is a old maximum demand. This is a old maximum demand. This is a base level maximum demand. Then 100 kVA. 100 kVA we are reduction. How it is possible? Because we are achieved the power factor 1. Then maximum demand is 3657.5. This is a maximum demand now, but the electricity company always calculating their incur the charging always 70% of contract demand. So contract demand always 5000 into 0.75. This is always their they charging this amount. So no need to minus this one. So this value minus this value, then you get it 100 kVA reduction. The 100 kVA, so then 100 kVA we got the reduction per month. Then 12 month for this cost reduction per year. 100 kVA per month into 12 month into 600 rupees. Totally 7,20,000 cost reduction. This is a one set completed. Next, incentives for poverty improvement. First we are calculating the KVA requirement. That KVA requirement, how much cost installment. 1 KVA equal to 900 rupees. Then total value you calculated. Next, if you are added the KVA rating, then maximum demand always going to reduce. Then how much maximum demand reduce? Then you calculate the maximum demand. Then company EB always giving the charging is maximum 70% is maximum demand. Then 70% is 5,000 equal to 3,750 the maximum demand. Then already we have the 3,850 minus 3,750, then 100 kVA. This is a 100 kVA. We have to calculate this how much cost reduction. Then 7,25,000. This is a cost reduction. Now another one cost reduction is power factor improving. They are giving the incentives for the monthly bill. The monthly bill already we are paying 18 lakhs. Then we are improve the 0.95 to 1. Total percent 2.5%. Monthly bill is 18 lakhs into 2.5 divided by 100. Then 45,000 per month. The cost reduction. We have to calculate always. We have to calculate yearly. So 5,40,000 into 12. Then total saving electricity bill. This is a maximum demand reduction. This is maximum demand reduction. This is incentives. Total reduction 12,60,000. Then investment for the capacitor. We already calculated 10,82,700 rupees. Then playback period, how long it will take. We are going to invest this amount. Then this amount how long take. This amount how long take to reduction. So investment divided by savings. Investment equal to 10,82,700 divided by total saving. The saving is power factor improvement. They get the incentives plus maximum demand reduction. So 0.859 years into 12. You put it into 12. Then just I write it 0.859 into 12. Then you got it 10.39 month. 31 month. This is a period. You have to calculate how they given the mark for this. So we need to calculate the annual reduction maximum demand charge. This is one they already asked, and KVA rating second, and energy charging component that, and playback period. If this is easy, just command me below the attachment.